Okay, we're asked that the first photoelectrons are emitted from a copper surface when the wavelength of incident radiation is 282 nanometers. What is the threshold frequency for copper? What is the work function for a copper surface? So the threshold frequency is the frequency below which no photoelectrons can be ejected. And by saying that the first photoelectrons are emitted tells us that the wavelength that we've been given corresponds to the threshold frequency. So the threshold wavelength is 282 nanometers, and therefore we're asked for frequency. Well, we know that the velocity is the wavelength times the frequency, and as we want the frequency, we divide both sides by wavelength to find frequency is equal to velocity divided by wavelength. The only way you could now make a mistake is by doing units incorrectly. So let's not make that mistake. Velocity of light, 3.00 times 10 to the 8 meters per second. And therefore the wavelength must also be in meters. A nanometer is 10 to the minus 9 meters, so we can make an algebraic substitution for nanometers. That is 282 times 10 to the minus 9 meters. And we don't write it in, but you can always think that 282 nanometers actually means 282 times nano times meters, and nano means 10 to the minus 9. So there we go. We calculate the number and we will have the threshold frequency. .06 times 10 to the 15 per second, because the meters cancel with one another, which per second can also be written as hertz. The second part of the question asks what is the work function for a copper surface. Well, the kinetic energy of an electron ejected from a surface is equal to the incident energy of the photon minus the work function of the surface. And at threshold, this kinetic energy is equal to 0. We're just ejecting electrons, they don't have any excess energy, and as the photon energy minus the work function is equal to 0, we can write that the photon energy is equal to the work function. And the photon energy we calculate from energy of a photon is Planck's constant times the frequency, which in this case is therefore Planck's constant times the threshold frequency. Planck's constant 6.64 times 10 to the minus 36 joule seconds times frequency of 1.06 times 10 to the 15 hertz is per second, which I can just write as per second, and then we can see that the seconds and per seconds cancel with one another, and we're going to have an answer in joules, and this answer will be equal to the work function equals 7.03 times 10 to the minus 21 joules, at which point I can see immediately that I have made a mistake. And the reason I can see that is I expect all work functions to be of order 10 to the minus 19 joules, in other words close to 1 or so electron volts. So I've made a mistake of a factor of 100, and it isn't in my frequency, because I have written down my constant incorrectly. So 10 to the minus 36 is the wrong number. That should actually be 10 to the minus 34, and therefore 10 to the minus 21 becomes 10 to the minus 19. Okay, now I have corrected and calculated a sensible work function that's of order 3 eV or so. Fine. So let's just highlight the answers for the person who has to mark the work. You were asked for the threshold frequency and the work function, and that is what we have calculated. And we're done.